Yes, so welcome to next lecture of physics optional. Most probably this is the second 22nd one. Okay, so it is 22nd one. So in this second 22nd lecture, we are going to see one question. Examine whether examine whether the following wave functions denote realistic situation or not. We have to examine whether the given wave functions denote realistic situation or not. Okay, so the very first question is this: psi x is equal to a e to the power I kx. Okay, this is basically your what is you have to examine it. You have to examine it. Okay, so this is the equation of plane wave basically. This is the equation of plane wave, and it is such a equation that its wave front is planar. If you learn paper 1, then it will be more clear to you that why its wavefront is planar. But this is called a plane wave. That's why it is called a plane wave, because its wavefront is planar. Okay. Now I will write it like this. I will use the Euler's formula. I will use basically Euler's formula. So after I use the Euler's formula, I will get basically this cos kx plus I sin kx. Okay, and del psi by del x, if we find out, this a will come out, and what will the integration be? It will be basically uh, e to the power I kx into I k, right? When you take the differentiation of this by the formula of integration, exponential formula, you get this, which will be equal to your I k a e to the power I k x. Okay, I k a e to the power I k x. Now e to the power I k x, your e to the power I k x is clearly equal to this. Okay, so I will substitute its value over here. So you can clearly see this thing that it will be equal to this. We are basically examining the function. Okay, we are basically examining the function. And why we have done this? Why we have done this? Because we know this very well, that psi x and del psi by del x, that is the condition to be satisfied by a wave function for realistic situation. And our condition number 1 is that psi x and del psi by del x must be finite everywhere. Okay, they must also be single valued, they must also be continuous everywhere, and psi of x must be square integrable, right? Even if one of the situation is not satisfied, it is clear that it will not be a realistic wave function. All the conditions, all the four conditions which I told you in the previous lectures, all those four conditions must be satisfied, only then it will denote a realistic situation. Otherwise it will not denote a realistic situation. Okay, so this is the thing. Now now you can clearly see this, that psi x and del psi by del x. Okay, these are what finite for all x. Okay, these are finite for all x. Why there will be finite for all x? They will be finite for all x because you can clearly see this thing, that when you put the various values of x over here, over here when you put various values of x, you can clearly see this thing, that it will yield you a finite result. Okay, because cos kx and sin kx will vary between -1 to 1. Okay, sin kx and cos kx will vary from -1 to 1, -1 to +1, right? So as they will vary from -1 to +1, it will always yield you a finite value. Okay, so they are finite for all x. They are single valued also. Why they are single valued? Why they are single valued? Because for one value of x there will be only one value of, so it is a function of sine and cos, right? It is a function of sine and cos. Now if I put the various values of x, if I put suppose various values of x, then it will always be single valued. It will always be single valued. It will always be single valued. Why? Because you know this very well, that square root function yields two values. So square root function is not single valued. Okay, square root function is not single valued. But sin kx, cos kx, these functions are single valued, right? These are single valued because after putting one value of x, we will get only one value of the function. Okay, after putting one value of x, we will only get one value of the function. So it is single value, right? And also they are continuous too. Why they are continuous? You know this very well, that they will be continuous also. Okay, why they will be continuous? Because you know the graph of sinusoidal graph of sin x and cos x. You know the wave. Okay, so if you draw the graph of sin x and cos x, the sin x graph will look something like this. Okay, and if you draw the graph of cos x, it will look something like this. Okay, so they are continuous. There is no discontinuity. There is no point at which they are not defined. There is no point at which these functions are not defined. So they are clearly continuous also. Okay, now what is the example of discontinuous function? Tan theta. Tan theta is your discontinuous function. Okay, tan theta graph will look something like this. Okay, so it will be discontinuous function because pi by 2 n pi by 2 is the line of discontinuity. Over here there will be discontinuity, right? So tan function is clearly discontinuous function, but over here we have sine and cos as our functions. So as we have sine and cos as our functions, so clearly they are single valued. Okay, and as they are single valued, and they are also continuous. Okay, continuous. So they satisfy these conditions. Which conditions? The conditions which I told you in the previous class. Which condition? Condition number 1, that they must be finite everywhere. So over here condition number 1 which I told you in previous class is satisfied. Okay, single valued. Single valued means condition number 2 which is given over here is satisfied. Okay, and then continuous. Continuous everywhere. Continuous means we can draw its graph without lifting the hand. If I say continuous and discontinuous function in an informal way, if I tell about continuous and discontinuous functions in an informal way, so clearly these functions will be continuous because their graph can be drawn without raising the hand, without raising the pen. Okay, so they are continuous functions. Okay, so this condition is also satisfied, which was the condition number 3 which I had discussed in the previous class. Now they must also be square integrable according to condition number 4. So let's see whether they are square integrable or not. Okay, let's see whether they are square integrable or not. So I will just take it like this. Okay, this is from the definition of complex number. This formula comes from the definition of complex number, that modulus of complex number square is equal to complex number multiplied by its conjugate. Okay. Now psi x value we already know, a e to the power I k x. Psi x value we all already know. So a star e to the power I k x star, right? It will be like this. And your psi x will be a e to the power I k x, right? So clearly I will replace this I by minus I. So it will be minus I k x. Okay, a e to the power I k x. Okay. So after applying the laws of indices, these two terms will be cancelled out. Why they will be cancelled out? Because they will yield you, they will give you e to the power 0, and e to the power 0 is 1. So I am clearly left with a star a. I am left with a star a. Okay. Now a star a is again, it as it is a complex number, so it can be written with by the definition of complex number like this. Okay. Now one thing is very remarkable over here, that if I take the integration of this, okay, if I take the integration of this dx is equal to a mod a square integration minus infinity to infinity dx. Okay. Over here I have substituted mod a square. Okay. So now you know this very well, that mod a square will come over here, and x will come over here, and minus infinity to infinity will come over here. So mod a square infinity minus minus infinity. Okay. So it will be mod a square multiplied by 2 times infinity. 2 times infinity, I should not say like that. It will be wrong to say 2 times infinity, because infinity minus minus infinity will be in fact again infinity. Okay. It will be again infinity. There is nothing called as 2 infinity, it is infinity only. Okay. So it is in turn infinity. So it is basically not finite. Okay. So infinite value has come. Okay. So clearly I can write like this, that minus infinity to infinity psi x square dx is equal to infinite, that is not finite. Okay. So it is not square, that implies that it is not, it is means psi x is not square integrable. Psi of x is not square integrable. Okay. So again we can have done it without, we could have proved, we could have proved this thing. Which thing? We could have proved this thing by one more thing also. We could have proved it in another way too. And that another way is as follows. Okay. That another way is as follows. You clearly know this, that our square of modulus of psi x has come out to be equal to a constant. Okay. Because mod a is a constant. Okay. Modulus of complex a is a constant, so it has completely come out to be a constant. Now this is unphysical. This is unphysical or unrealistic. It is unphysical or unrealistic because it is unphysical or unrealistic because why it is unrealistic? The reason is very simple. Because suppose the experiment is happening at Delhi. Okay, because suppose the experiment is happening at Delhi. Suppose your experiment related to electron is taking place at Delhi. Suppose your experiment related to electron is taking place at Delhi. Okay, so naturally the probability of the electron to be found at Delhi must be more than its probability of being found at USA. So its probability of being found at Delhi must be more than its probability of being found at USA. Why? Because the experiment is taking place at Delhi. So it is very difficult that the electron will reach up to USA. Okay. So its probability of being found at USA must be less than. Okay. So probability of being found at USA must be less than probability of being found at Delhi because the experiment is taking place at Delhi. Okay, but according to the probability density, this is what this is basically probability density. Okay, this is what is probability density. Okay, so but in our result we have got probability density to be a constant. We have got probability density to be a constant. Okay, in our result we have got it like that. Okay, so clearly according to our result the according to our result what is there according to our result probability at USA is equal to probability at Delhi. Okay, even when experiment is taking place in Delhi, even when experiment is taking place in Delhi. So what does this denote? This clearly implies that this result is ridiculous as the probability density must decrease with distance, as the probability density must decrease with distance. Okay, as the probability density must decrease with distance, so clearly Okay, so this denotes a ridiculous situation, right? So that implies that our wave function psi of x does does not represent a realistic. So our wave function psi of x does not represent a realistic situation. So that's why it does not represent a realistic situation. So either you can find out the integration and tell that the integration value has come out to be infinity, or either you can directly jump to the conclusion. I have written so much because you should understand. Okay, I have written so much so that you can understand, but in the exam no need to write this much, as the answer will become very lengthy. In the exam directly write probability density is equal to constant, which is ridiculous, okay, unphysical. Like that you have to directly write. You don't have to explain this much in the examination, real examination. Okay, so that's all for now. In the next class I will discuss one more wave function which has to be examined whether it represents a realistic situation for wave function of electron or not. Okay, so I will do it in the next class. Thank you very much.